welcome to limits of rational functions. So the idea here is that rational functions have end behavior that's fairly simple to determine. Or at least fairly quick to determine algebraically. And what we will do is we will take advantage of the fact, we use the fact that the limit as x goes to either positive or negative infinity of 1 over x to the n is always 0 for n positive integer. And so what we can do is if we want to take some limit as x goes to either plus or minus infinity of some polynomial, let's say x cubed minus 3x squared plus 5 over x squared minus 2x squared plus 4. If we just, 2x, we don't need another x squared. If we look just for the highest power we can find, so in this case, x cubed is the highest power. If we go ahead and multiply the top and the bottom by 1 over x cubed, we can turn everything except that any term with an x cubed into something that will go to 0, right? So we're looking at the limit as x goes to plus or minus infinity of 1 minus 3 over x plus 5 over x cubed. And then we have 1 over x minus 2 over x squared plus 4 over x cubed. So you see that every term, all of these will all go to 0, right? And so we can take advantage of this fact and quickly simplify our problem so that we essentially are only dealing with the highest powers and everything else goes to 0. So in this case, the numerator would go to 1. So anything in blue goes to 0. The numerator goes to 1, the denominator is going to 0. And so if we're dividing 1 by 0, we would wind up with either a positive or negative infinity. And in this case, so we'd wind up with either a plus or minus infinity. The general rule is if we have a rational function f of x is equal to p of x over q of x. And let's say that p, reminder, the degree of a polynomial is the highest power of the polynomial. So if we have a rational function, p of x over q of x, first, if the degree of p of x is greater then the degree of q of x. Then we get that the limit as x goes to plus or minus infinity of f of x will go to either plus or minus infinity. To do that more precisely, you will then have to simply check, will the polynomials be positive or negative when x is either negative or positive, and close to negative and large negative numbers or large positive numbers. 2, if the degree of p of x is less than that of q of x, then the limit as x goes to either plus or minus infinity of f of x is 0. The denominator will go to infinity faster than the numerator, and so we'll head towards 0. And if the degree of p of x equals that of q of x, then the limit as x goes to plus or minus infinity of f of x is simply the fraction that's made up of the leading coefficients. So this next one is an example of that, right? So we have, oh, sorry, then this next one, we have 3x squared plus 2x minus 1 for our numerator, 6x cubed minus 4x squared for the denominator. And our job is to find the limits at infinity. So if we want to find the limit as x goes to negative infinity of 3x squared plus 2x minus 1 over 6x cubed minus 4x squared. The highest power in each polynomial, so the highest power here, we have degree 2, versus on the bottom, the highest power we're looking at, we have degree 3. So our denominator will overrule. So the denominator has the larger degree. And so that means that this limit is equal to 0 by the same argument. So this is number 2 from our rule. Similarly, the limit, I don't know why I wrote find, the limit as x goes to positive infinity of 3x squared plus 2x minus 1 over 6x cubed minus 4x squared is also equal to 0. So again, we look at the degrees. The denominator in this case overpowers, so the denominator will go to infinity faster, and dividing by infinity ultimately takes us towards 0. Now let's consider the function g of x equals 2x cubed minus x plus 5 over 3x squared plus 2. So here we have degree 3 up top and degree 2 down below. So that means that our numerator in this case will overrule. So we know that the limits as we go to plus or minus infinity of g of x, that we are looking at either positive or negative infinity. So something to look for here, 2x cubed minus x plus 5 will take the sign of the leading coefficient as x goes to positive infinity, and it will be negative as it goes to negative infinity. 3x squared plus 2 will take the sign of the leading coefficient for both. So if we split this more specifically, the limit as x goes to negative infinity of g of x will be negative infinity. And the reason behind that is a cubic function, 2x cubed minus x plus 5 versus 3x squared plus 2. A cubic looks like this, more or less, right? It goes negative versus a quadratic with a positive leading coefficient. Looks like this. So we will wind up negative over positive going to the left and positive over positive going to the right. So now when we do our second one, the limit as x goes to positive infinity of g of x will wind up being positive infinity. Now let's go ahead and consider the function h of x equals negative 3x squared plus 2x minus 1 over 5x squared minus 2. So in this case, we are looking at degree 2 up top and degree 2 down below. So this is a situation of case 3. So what we're going to do is we simply take the leading coefficients. Since they have matching powers, we take that negative 3 over 5, and that's what we will limit on. So the limit as x goes to, as x goes to either positive or negative infinity of h of x will simply be negative 3/5. So again, we just take those leading coefficients and form that fraction. So in the case where the denominator overrules, has the higher power, we go to 0. When the numerator and denominator have the same degree, we take those leading coefficients from a fraction. And in the case where the numerator has the higher power, we know we go to positive or negative infinity. You'll have to do a little more thinking to figure out which one of those it is.